unstretched state, the minimum value of M required to move the block of the plane is. Here capital M, I'll call M2, small m as M1. Minimum value of M, what do you mean by that? So when I release it, so next again, the minimum value of M required the block of Martin laid from rest with spring in action, the minimum value of M required to move the block up the plane. So this should shift. The block M1 should shift here. So first I'll release it. There's a thing. Now I'll release from rest here. So there's the initial diagram. Now what is the state of spring? The block will descend. Take like this now. For for the block M1 to shift, tell me what is the necessity condition. The spring must get elongated. Kx, then other forces acting are M1g sine theta and the friction. When the block M1 will shift, when Kx is, let me take it here, block M1 shifts when Kx is greater than M1g sine theta plus F. Is asking minimum, no? So I'll go for equal condition. Let me equate. So this is equal to mu mg cos theta. So we know sine theta, cos theta, and we know mu also. Let me directly get that value. Anybody value Kx? M1g sine theta 3/5. Mu is 3/4. M1g cos theta 4/5. So 2m1 6m1g/5. Keep it here. So this is the value of Kx. Let's come for this. So now what is the other thing? Something is asking M2 in terms of M1. I think that was the only thing that is given. So how to replace this Kx? So now, what is the state of the block, this particular block? I release it from rest. And this will be instantaneous rest. So to produce elongation of spring, to produce that elongation, how much the block M2 should descend? To produce elongation of spring X, and this will be at rest, only. The block will not shift. Just about to shift, we are discussing condition. So I release from rest, and let this be instantaneous rest here. So to produce elongation in the spring Kx, so how much of the block M2 should descend? It should descend by a distance x here. So let's write the conversion of the decrease in potential of block M2 is what? Converted into increase in elastic potential of spring. So the block M1, now what happened? When the block M2 reaches the lower extreme, then the block M1 is about to shift here. So therefore, the block M1 was at rest and it will retain that rest here. Very next moment here, so what happened? This will start shifting. Means further you increase the value of M2 further more, no, then it's going to shift here. So what is the kinetic energy of the block M1? Will be 0. And the M2 was released from rest and it is at lower extreme. So therefore, Instantaneous rest, I'll call it. Shall I write rest or instantaneous rest?
Instantaneous.
Instant rest. It will be oscillating. The block M2 will be here oscillating. And now the very first question, sir, why you're taking instant? Why not equilibrium? That's what the word minimum is what? I'm going to justify it. Now come for this. Decrease in potential G, M2 Gx should be equal to Kx square by 2. M2G equal to Kx by 2. So what is Kx equal to? 2mg, I'll write it. So equating 1 and 2. So what is value of M2? M2 will be 3 by 5 m. This will be your answer. Now few questions we have to really analyze. What are the things? What you have to understand? Why not this be at equilibrium? Block M2 when M1 is about to shift. When M1 is about to shift, let M2 be at mean position or equilibrium. Let me say at equilibrium. Then what you should write? Kx equal to mg M2g. Then you equate that and see what you'll get it. Substitute here. So M2G equal to 6 M1G by 5. Now, why can't this be answered? Why can't be?
Sir, by that we mean it is in equilibrium.
Wait. So, let me talk. In between, don't disturb. See, like now, what was the question asked? Find the minimum value of M2 required to move the block up the plane. You look at among this, which one is the minimum? Here that symbols M2 equal to 3M1 by 5. If you want to change further symbol, do the thing. No. So look at compared to this two, which is minimum? 6M1 by 5 or 3M1 by 3M1 by 5 is minimum. But sir, how do I come to in a problem where I should equate? You have to look at the mathematical situations, conditions, what they're given. Minimum value of M2. So when the block M2 is at lower extreme, then what will happen? The block M1 is about to shift. At lower extreme, you should not equate forces. Again, you should not write Kx equal to M2G. At lower extreme, the spring force will not be equal to weight. At mean position, spring force will become equal to weight. Then sir, at equilibrium, if you want, you should change this equation also. Again, decrease in potential G equal to increase in elastic potential G plus kinetic energy of the block M2. Here you have to make it. And work out again, you check it. You don't get answer. So this will be a wrong idea like this. Because at lower extreme, you should not equate forces. That's what it's telling. So either way, another way I'm trying to conclude here, at lower extreme, don't equate, don't say net force on the block will be zero. At lower and upper extreme, the acceleration will be non-zero. At mean position, acceleration will be zero. So what is the conclusion we can make it here? At lower extreme, lower or upper extreme, acceleration will be non-zero, velocity will be zero. At mean, velocity will be maximum, acceleration will be zero. So where you should equate forces, here you can equate forces, net force will be zero. So whenever the spring block comes, no, this is the basic idea one must have. Anybody having any doubt, you can ask it. Huh? This is something very basic one, which I picked up. Sir, what happens after shifting? Suppose if you make M2 greater than 3m1 by 5, 3m by 5, then before reaching this extreme only, the block M1 is going to shift. Able to analyze? If M2 is equal to say like a